Located in Central America, Costa Rica is a renowned tourist destination. The ecological commitments of its government aim to preserve this fragile isthmus connecting North and South America. Faced with climate change, the state has begun an unprecedented mission to manage its water resources. This study reveals the secret of the origins of Costa Rica.
Costa Rica es un país centroamericano, tiene una extensión de 52.100 kilómetros cuadrados, limita al norte con Nicaragua, al sur con Panamá. Costa Rica desde el 1 de diciembre de 1948 no tiene ejército, la educación es gratuita y obligatoria, la expectativa de vida, Costa Rica es un país independiente, democrático. La religión que prevalece es la católica, pero existe libre culto. El clima nuestro es de tropical, de aproximadamente 22 grados centígrados durante todo el año, y tiene dos estaciones, una seca y una lluviosa.
Emerging from the waters 5 million years ago, this paradise on Earth contains 6% of the planet's biodiversity. But intensive farming, demographic growth, and climate change are leading to imbalance. As a scientist, the ex-ambassador of Costa Rica, Mr. Roman Macaya, has created the concept of science diplomacy.
And so when I was named ambassador, I thought, what is at the intersection of science and diplomacy? And this is very important for a developing country. We don't have the luxury of making many mistakes. And so if we can use data, information, and technology to make better decisions, well, that is certainly going to help us in our development.
In 2014, Mr. Roman Macaya met Dr. Saud Amir, expert in remote sensing for the U.S. Geological Survey of the American Geological Institute. Dr. Amir travels to countries affected by war and natural catastrophes to evaluate water requirements for the population. His expertise leads to long-lasting scientific solutions. Roman Macaya told him about the problems in Costa Rica with the disparity in water resources and the question of economic development.
I asked him what USGS can do to map underground water. I mentioned that in Costa Rica, in some parts of Costa Rica, like the Guanacaste province, our development is limited by the availability of water. Freshwater availability and issuing water rights was a very contentious issue.
And I said, yes, this is very in line with what we do, and we might be able to help you, giving you the tools to make a more informed, scientifically based informed decision. Costa Rica is developing, it's growing, so I think it would be wise, because this is a one-time study, you know your water resources, so at least you can divert development when it's needed and based on demands to other parts rather than slowing actually the development process.
Saud Amir's project has been approved by the Costa Rican authorities. For the environmental minister, this study will enable them to build a long-term water strategy.
El estudio se plantea una urgencia que teníamos en el momento dado, digamos, en el 2015, de atender una situación muy concreta que era Guanacaste. Pero cuando se conversa ya con Saud y con el Servicio Geológico, vemos el potencial que tiene el uso de estas nuevas tecnologías para no hacerlas solamente en Guanacaste, sino hacerlo en todo el país. Asuntos, por ejemplo, de potenciales de usos de no solamente que nos dijera dónde están los acuíferos, sino que habláramos también de las calidades. Bueno, uno de los resultados que acabamos de oír, por ejemplo, nos dice Costa Rica tiene un gran asset, un gran recurso que ha sido los parques nacionales que precisamente están ubicados exactamente donde necesitamos tener las zonas de recarga. La fotografía que se nos presenta es una fotografía lindísima, sustentada en un producto, en un resultado totalmente científico, donde no interviene la política en nada, es totalmente científico, totalmente replicable. Y eso es lo que viene a nutrir exactamente una buena política pública.
Definitivamente poder tener tecnología satelital de punta como esta que estamos teniendo a través del proyecto es importantísimo para poder tener acceso a lugares donde no podríamos mapear o tardaríamos muchísimo tiempo en tener este mapa. Gracias a esta tecnología es que podemos tener un mapa completo del país en muy poquito tiempo en sitios a donde antes no hubiéramos podido llegar.
Being the coordinator of the project, based on my experiences, I reached out to Dr. Gachet. Since I have worked with him for many years, we did several other areas, and his approach in terms of combining the remotely sensed data with the ancillary and observed data presented to us the most successful results everywhere we worked.
Saud Amir met Dr. Alan Gachet during the humanitarian crisis in Darfur in 2004. He audited the method called WATEX for water exploration when Alan Gachet was carrying out an inventory of the groundwater. It was urgent to find water for 250,000 people who were moved to Chad and 3 million to Sudan. Since then, the WATEX method has been improved to identify water resources called aquifers, up to 1,000 meters deep. Dr. Gachet is responsible for Phase A of the mission, which consists in studying the geological structure of Costa Rica with the WATEX remote sensing tool. The very first geological data recorded about Costa Rica dates back to pioneers during the digs on the Panama Canal in 1914. Knowledge of deep geological structures comes from the seismology studied by the petroleum sector. As for tectonics, studies of multiple earthquakes and volcanoes in Costa Rica constitute a considerable database for analysis. Associated in the project, experts and research specialists from institutes and universities in Costa Rica are developing and improving the database.
Mi nombre es Ingrid Vargas Azofeifa, soy geóloga de formación, hidrogeóloga. Trabajo en la Escuela Centroamericana de Geología de la Universidad de Costa Rica. Dentro de mis actividades están la docencia y la investigación, así como también la acción social. Durante los años 2009 hasta el 2013 realizamos una investigación conjunta entre el SENARA y la Universidad de Costa Rica para investigar una parte de la margen derecha del río Tempisque.
From his office in France, Alan Gachet and his colleague, geologist Delphine Savest, are carrying out the study of Costa Rica by bringing together 3 types of information: geological, geophysical, optical, and radar remote sensing images. After having gathered, with the help of Costa Rican institutions, all the elements, geological, geophysical, structural, data about wells, including petroleum data, climate data, rainfall, we were able to assemble all of the data using our expert system called WATEX, water exploration, to produce this type of document, which is totally original, that is a hydromorphic ground map, perceived through the clouds and the forest. So, to get a good understanding of deep water exploration in Costa Rica, you must get a good prior understanding of how Costa Rica came into being. In an area where continental drift plays an essential part, and in particular, subduction of the Pacific Ocean plate, which passes under the Caribbean plate. It was necessary to do a detailed analysis of images from the American Space Shuttle under the clouds and under the forest, mapping precisely precisely the fractures in detail to understand that Costa Rica is divided into three parts. There is a part which is materialized here in blue, the other one in the center in green, and here, the southern part in red. The northern part is pure compression. Both plates, the Cocos and the Caribbean, are in conflict, and that makes it an area of pure compression. The same thing here, in the red part, a pure compression area. However, the area in the center is a dislocation area because the Cocos plate moves quicker here than the northern plate. In other words, along the shear corridor, there is a difference in speed between one plate, which advances 7 centimeters a year, and the other 9 centimeters a year. There's a difference of 2 centimeters per year, which means that Costa Rica is going to shift there in a full shear axis, which is going to make it slide in this direction, which is the Hess escarpment, and all the seismic area which is going to develop from this as far as the overlap here in Panama. So all of this area is evidently an earthquake area, which is well known in Costa Rica. The port of Limón is this way, therefore very exposed to earthquakes. However, there is an opening here which occurs the whole way along the S escarpment, and it is in this area of opening, and therefore the collapse of the basin, that we will find the deep aquifers. In the northern part, here in blue, there will not be deep aquifers here. Everything is compacted. It is pure compression. In the southern part in red, it is pure compression. Here in the center, in green, there is rifting. Rifting opens up faults, which enables deep water to circulate, which will feed the aquifers in the Tortuguero-Sarapiqui basin. In the field, we discovered along this line extremely important geothermal occurrences. They exist. They have been proved. The consequence of all of this has very important implications for geothermics, civil engineering, road construction, along these extremely active fault lines. The Trans-American Highway, which joins North America to Panama, goes through this segment. And here, hydrothermal occurrences from very deep underground water which rise with all the mineralized colors of iron, magnesium, and rare minerals. The Earth's response is the response of humidity, which we are looking for. The red parts are really reserved for the forests, which doesn't mean that the forest is dry, but under this forest, there will not be any superficial aquifers between 0 and 60 meters. And we can see these yellow and blue multicolored areas. So already, at first sight, to do inexpensive drilling between 0 and 60 to 80 meters, we can preferably set it up in areas which are yellow, and then light blue, and then dark blue. We will increase at the moment either the depth or the risk. If Alan Gachet needs to refer to his land maps, it's to confirm his forecasts. He will be leaving for Costa Rica very soon. Several sites are to be identified to understand the water system, elaborate aquifer systems, identify faults, interaction between above and below, and the relative movement of tectonic plates. Perfect coherence of the maps with the land will enable him to detect deep aquifers. The French and American teams will be meeting in San Jose in September 2018 to present maps to experts from MINEA and different units of the water management authorities. Sira Carrillo is coordinating the teams of experts in Costa Rica.
El proyecto que estamos en este momento con el Servicio Geológico de Estados Unidos nos permite tener un conocimiento integral de la información del recurso hídrico subterráneo a nivel nacional, aplicando la tecnología WATEX, que ha sido muy importante sus resultados. Hemos hecho validación de campo de los resultados obtenidos y han sido muy satisfactorios.
Young geologists from all over Costa Rica will be attending and commenting the results.
My name is Nancy Quesada. I'm from the north part of the country, in this zone. I'm the coordinator of the Unidad Hidrológica San Juan. I'm an agricultural engineer. This project is very important for some decisions that the direction of water needs to take. For the remote sensing and the seismic is my first touch with these systems. It's very interesting. The results that we can see, the lever of results is very impressive.
My name is Jorge Blanco. I work from the Dirección de Aguas. Water Department of Costa Rica. I come from the southern part of Costa Rica, the Terraba unit. This northern area of Costa Rica has several problems with water. There are fights for years. Also, this part at the south of Costa Rica has many problems with water supplies, especially in summer. So with this project, we are trying to find the right places where is the water resources in Costa Rica, so we can supply people at the future with this research.
Mi nombre es Nazaret Rojas, trabajo en el Instituto Meteorológico Nacional. Este proyecto también ha sido de gran beneficio en la mejora de las metodologías para definir la evapotranspiración.
For yesterday, we chose the priority areas based on a discussion with the technical working groups here in Costa Rica, and we used those WATEX map to come up with the best water use by using our optimization economics model.
Phase A of the mission will end with on-site use of the navigation and exploration system of underground water resources. Alan Gachet has identified targets that the young geologist must identify, like geothermal energy and the fault system. This tablet contains a territorial database specially created for Costa Rica.
Mi nombre es José Manuel Jiménez, yo soy geólogo de profesión. Yo escogí la carrera de geología porque me apasiona el trabajo de campo. Me gusta analizar las rocas, me gusta comprender cómo fue que se formó todo un país. Este sistema que nos viene a enseñar, esta herramienta que nos están proveyendo la USGS, es muy innovadora en nuestro país. No solo las tablets, sino que todo el proceso de generación de mapas ha sido muy enriquecedor, y a nivel profesional y personal siento que es de una gran ayuda lo que nos están proveyendo la USGS.
My name is Daniel Conejo. I'm a geologist and I work in the Liberia office in Guanacaste. Lo que estuvimos haciendo el día de hoy fue utilizando el GIS. Primeramente lo que queríamos hacer era comprobar algunos sitios que en el mapa de WATEX aparecían como zonas con alto, medio y bajo potencial para perforación de pozos. Entonces lo que hicimos fue un recorrido desde San José hasta Orotina, para lograr identificar algunos puntos donde identificamos alteraciones hidrotermales en las rocas, algunos sitios donde afloraban puntos de agua. Entonces lo que logramos comprobar con esto fue que la información general que nos brinda la aplicación de WATEX funciona muy bien para poder identificar sitios para perforación.
Experts are going to propose priority zones for the B component of the mission, the hydrogeological evaluation.
Then I reached out to Dr. Wayne Belcher, who is a hydrogeologist from the USGS. He has a very good experience in taking the outcome of the remotely sensed data from the work that Dr. Alan Gachet used in other areas to build a conceptual model.
My everyday work is I develop hydrogeologic conceptual models of groundwater systems. And that is my role on this project, is to take the information that's done from component B, the remote sensing work that's done by WATEX, and then I will take that information and other ancillary information and construct a three-dimensional model of the hydrogeologic units, which consists of the aquifers and confining units, to estimate the volume of water that's contained in aquifer systems in Costa Rica.
The three designated zones are located in the north, center, and south of Costa Rica. Alan Gachet has drawn up geostructural cross-sections as deep as 4,000 meters. He is presenting the cross-section which goes from Guanacaste and crosses the capital, San Jose's catchment area. Let's move on to the Nicoya Peninsula. In the Guanacaste region on the Pacific coast, down to the Caribbean coast with the San Carlos Basin. And we can see that all of Costa Rica, in the northern part, is subject to pure compression, and the seismic structural style shows indeed the effects of this compression, where the sedimentary layers fold like an accordion under this compression. and the upward movement of the sedimentary parts of these basins sandwiched in this compression. The majority of the marine sediments, which would have been of interest for storing water, have been brought up and basically eroded, only leaving at the surface deep marine series, which are of no hydrogeological interest whatsoever. Now, let's go into the central zone, which is subject to tearing and this rifting effect. It changes everything. All the other parts which are exposed between the San Jose Basin, as far as the Atlantic coast along the Hess Escarpment, are going to distend, leaving room for faults which are considered normal. Basalt in the San Jose region is fractured in the right direction. This is mainly the basalt fracture in the first 150 and 200 meters only, which enable an abundant increase in fresh water for the capital. Now, the real potential, if we really want to go industrial, industry should be done on these opening zones of the basin and in all of this sedimentary area fed by open faults. We are likely to find first-class aquifers. That is the wealth of Costa Rica.
We traveled with the GENS, the Groundwater Exploration Navigation System, where RTI, Dr. Gachet, put all the maps, georeference maps for the shallow aquifers and deep aquifers. And as we were traveling along from San Jose to Guanacaste, we were able to look at the maps, and it fits very well what we have seen in terms of the high, medium, and low potential water.
And as we drove around, we looked at areas where there was very little green vegetation. Virtually the only green vegetation we've seen is where it was being irrigated for agriculture. It's in an area that is been identified by RTI, by Ellen Gachet, as a compressive zone. And to the south of us is another zone that is extensive and has potential for water supply because it's all fractured and the fractures tend to be open. And then to the south and the southeast part of the country, there's another compressive zone.
This component is very important after we have mapped the groundwater using remotely sensed data with the WATEX technology, is that how our counterparts in Costa Rica, they would be able to develop different areas in a sustainable manner, that's the whole goal of this study. This wealth of information will be given to our counterparts, and then they will be able to, as the need for the country in developing some other areas, what would be the best use or uses for their water resources based on the competing resources. Because in Costa Rica, there are a lot of competing resources, the cities, the industry, the tourism, the agriculture. So there will be what would be the best use or uses for this water. I have been also working for many years with the New Mexico State University in Las Cruces with Dr. Frank Ward and Dr. Dina Salman. They are the expert in using optimization models to optimize sustainably the resources that we are looking for.
The big challenge here in Costa Rica is that the culture of Costa Rica values environmental protection in a very important way. Our plan is to help the farmers and the water managers decide how to best use that water once it is discovered more precisely. And so our connection to Alain Gachet and to Wayne Brashears is to take their information and help the government people decide how, on their own, how to economically best use the water for long-term economic sustainability and even environmental sustainability. aquifer protection is good for future farmers as well as future urban dwellers, it is very important. You cannot sustain economic benefit from the aquifer unless you sustain the aquifer itself. So sustaining the aquifer is good for the farmer in the long term, although it may cost some small amount of use and economic activity in the short term.
The groundwater is your saving account. When people ask me, is the water will be here indefinitely? And I said, well, if you have a saving account, every year you have dividends. If you spend only your dividends, your account will be there forever. If you spend your dividends plus little bit of your account, then your account will not be there forever. So the hydrogeology will be able to let the professionals here in Costa Rica on how to use their water resources in a sustainable way.
Supply of deep water resources in Costa Rica depends on its complex primitive structure. Because of these tectonic movements, seismic activity shows that there is tectonic extension, which enables a sedimentary basin to be created, open, subsident, and which generates an underground delta, which can contain very large quantities of water several kilometers deep. We can see that all of this is controlled by the differences in progression in the subduction of the Cocos Plate combined with the Hess Escarpment, which is almost the equivalent on the Caribbean side. We can mention the magical nature of the forest, which retains all the water which falls in large quantities every year on the Central Mountain Range. The rest is science at its purest state. So why did we discover what others did not discover before us? Because we put everything together into the same expert system, which brings together all of the plural-disciplinary data. And the result is the coherent summary of all this data, which enables us to reveal resources and an entirely new context.
The fourth component is the capacity building, which is transferring the technology to our counterparts in Costa Rica on how we develop the conceptual model and the economic assessment using the outcome of WATEX. And this is new approach on how to use WATEX in terms of doing hydrogeology and optimization model.
La metodología WATEX, que fue el primer componente del proyecto, nos hemos venido a ver justo esa importancia. Hemos estado trabajando en conjunto alrededor de 12 instituciones diferentes que tienen relación directa con el aprovechamiento, el manejo y hasta de manera indirecta como son los desarrollos en cuanto a lo que es el recurso hídrico. Después de que la metodología WATEX nos caracterizó los sitios potenciales donde podríamos encontrar agua subterránea, hemos pasado a otro nivel, que es optimizar ese recurso. Entonces, mediante una metodología hemos estado aprendiendo y desarrollando una optimización del recurso tomando en cuenta aspectos socioeconómicos, culturales, de proyección de crecimiento de la población en Costa Rica, para así, ya que sabemos cuánta agua tenemos, cómo utilizar el agua de una manera apropiada, tanto para el desarrollo del país como para la protección del medio ambiente.
The way I see it is that the end of the project here is the beginning of the work to many Costa Ricans here from the academia and from the research community.
Initiated by Costa Rica and the USGS, science diplomacy based on new technology has enabled unprecedented knowledge in the field of natural resources to be revealed. Securing the future for Costa Rica is a necessity. The scientific report from this study will enable politicians to make essential decisions for the economic future of Costa Rica, a key country with regards to ecology. Land use planning depends on it, with the social and environmental dimensions which have built the reputation of this beautiful country. Anticipating the future using science is self-evident because children and education are the pillars of a society which has abolished its army in order to be able to better adjust to the environmental challenges.